Unit 3A, Lesson 2. In this lesson, we're going to discuss different types of variation, working with those equations, and then we're also going to graph many different types of equations, looking at special points or special characteristics for each of those graphs. First, we're going to discuss the different types of variation. There's direct, inverse, and joint variation. The constant of variation is going to be represented by k, just represents some number that's being multiplied throughout the equation. Direct variation is in the form y equals k times x. Y and x are variables. K is that constant. Inverse variation, y equals k divided by x. And then joint variation is very similar to direct, except now we have two variables being multiplied. We have y equals k, that constant, times x times z. The first graph we're going to review is a parabola, which we know is the graph of a quadratic equation. So we have y equals x squared minus 2x minus 8. When we're talking about a quadratic equation, some key parts we want to be able to find and graph are the x-intercepts and the vertex of the graph. There's an expression we have to remember in order to find the vertex of the graph. It's x equals negative b divided by 2 times a, which in this case would be the opposite of negative 2 is a positive 2 over 2 times the a value, which is 1. So 2 divided by 2, the x value of the vertex is equal to 1. That's what this expression gives us. In order to find the y value, we simply have to plug this x value in to the original equation. So we have 1 squared, which is 1, times, or minus 2 times 1. So 1 minus 2, negative 1 minus 8. The ordered pair for the vertex is 1, negative 9. So we can go over on our graph and plot that point down 9. Now we need to find the x-intercepts if there are any. So we could take our original equation and try to factor this. This factors into x minus 4 times x plus 2. If we would use the zero product property, set each of those factors equal to 0, we get x equals 4 and negative 2. So on our graph, we mark those x-intercepts. We have negative 2 and 4. Using those 3 points now, we would construct a smooth curve that goes through all 3 points. If we look at our a value, it was 1, which is positive, so we know our graph is going to open up. It's going to form a smiley face. Next, we're going to review how to graph a circle. So we have the equation x plus 2 quantity squared plus y minus 3 quantity squared equal to 16. You have to recall the general formula for the equation for a circle. It's x minus h quantity squared plus y minus k quantity squared equal to r squared. So the two main things we need to identify in this case is the ordered pair hk, which represents the center of the circle, and then we need to find the value of r, which represents the radius. So in this case, the value for h and k, the value of h is going to be a negative 2. We have to think of this as x minus some number. So if this is x plus 2, that's the same as x minus a negative 2. And then the y value, or the k value in this case, is going to be 3. The radius, we have to look at this value of 16. That is the same as 4 squared. So our r value in this case is 4. That represents the radius. To graph the circle, the first thing we do is plot the center point, which was negative 2, 3. From there, we're going to plot some points using the radius. So if I go straight up 4 units, from there I can mark a point. If I go to the left 4 units, I can mark a point, down 4, and to the right 4. Now we construct a circle that goes through all 4 of these points around the center. So using a compass, we construct that circle, and that's the process for graphing a circle when given the general equation. To end this lesson, we're going to go through how to construct the graphs for basic sine and cosine functions. We're going to relate to the unit circle to construct these graphs. So looking at the coordinate plane, for my x values, Each of these tick marks represents pi over 2. So this would be 0, pi over 2, pi, 3 pi over 2, and then 2 pi. Going the other way, negative pi over 2, negative pi, and so on. The y scale I have going by increments of 1 for each tick mark. So here's 1, 2, 3, 4, 5, negative 1, negative 2, so on. Over to the left, I have the start for 4 different ordered pairs that we're going to use to plot some points and make a rough sketch for the graph. So using the unit circle, if we have a radian measure, angle is 0, what is the corresponding y value for that ordered pair? Remember, sine relates to the y values for the ordered pairs. So when theta is 0, the y value is 0. So we know that must be a point on the graph. 4 pi over 2, the corresponding y value in that ordered pair is going to be 1. At pi, the corresponding y value is going to be 0. And then at 3 pi over 2, the corresponding y value is negative 1. So we can go through, plot those 4 points, and then we're also going to find some points when our x values are negative. X is going to the left. And we have to use ideas of coterminal angles that we talked about before, 2 angles that start and stop at the same endpoint when thinking about the unit circle. So 0 is going to be the same theta value as negative 2 pi, which means they will have the same y value. So we know negative 2 pi and 0, that's going to be an ordered pair. Pi over 2 correlates or is a coterminal angle of negative 3 pi over 2, so they are going to have the same y value of 1. Pi and negative pi are coterminal, they will have the same y value. And then negative pi over 2 and 3 pi over 2 are coterminal, they will have the same y value. Now we can go through and plot these points, starting with this bottom one, negative pi over 2 and negative 1. So going on my graph, here's negative pi over 2, negative 1. I can construct that point. Negative pi 0, negative 3 pi over 2 and 1, and then negative 2 pi 0. Also, I know if I have negative 2 pi, 0, and 2 pi, a positive 2 pi, that will be 0 as well. So now I have all these points graphed. We know it looks like a general wave, so we can construct a curve that goes through all of these points. So you can construct the smooth curve, and now you have the graph for the basic sine function. We use the unit circle to find some specific ordered pairs, some specific values that we know, plot those points to construct that curve. We would use the same process in order to graph the cosine function. We would take those basic angles for theta, 0, pi over 2, pi, and 3 pi over 2, and then the coterminal angles, negative 2 pi, negative 3 pi over 2, negative pi, and negative pi over 2. Using the unit circle, when we're looking for the corresponding values for the cosine function, cosine relates to the x values of the ordered pair. So at an angle theta of 0, we're looking for the x value of the ordered pair, which is 1. At an angle measure pi over 2, the x value is 0. At pi, it's negative 1, and so on and so forth. And we can get the rest of these values. So plotting those points on our coordinate plane, we have the same scale as last time, pi over 2 for the x values, and for the y values, a scale of 1. We can draw a smooth curve through those points. So you have to remember, sine corresponds to the y values of the ordered pairs on our unit circle. Cosine relates to the x values of the ordered pair on the unit circle. The last thing in this lesson now is we're going to graph the equation for y equals 2 times the cosine of x. So the only thing we change from the first graph to this graph is now what's being multiplied by a value of 2. Recall what we talked about in a previous lesson. This affects the amplitude of the graph. It just changes how high or low the graph is going to go. So all of these theta values for ordered pairs are going to be the same. The only thing that's going to change is we have to multiply all of these y values by 2. So looking at our first value, when theta is 0, our y value, instead of 1, we multiply that by 2. Now that's going to be a value of 2. At pi over 2, 0 times 2 is still 0. At a value of pi, now rather than negative 1, we'd be at negative 2. come back. At 3 pi over 2, we'd be at 0, and at 2 pi, we'd be at a value of 2. Same process going to the left. Negative pi over 2, we'd be at 0. Negative pi, we'd be down to negative 2. Negative 3 pi over 2, 0. And a value of negative 2 pi would be 2. Then you would construct a smooth curve going through all those points, and you have the graph for y equals 2 times the cosine of x. In this lesson, we reviewed direct, inverse, and joint variations. We talked about how to construct the graph for a parabola, a quadratic equation, reviewed how to graph a circle by identifying the center and the radius, and then to end the lesson, we talked about how to graph the basic sine and cosine functions, relating those ordered pairs on our graph to the unit circle.